Alright, I made a video on how to carry out hemoglobin genotype using electrophoresis machine, and people demanded that I should do how to read the results. So in this video, I'll be showing you people how to read the results. So firstly, you should understand what is hemoglobin. Hemoglobin is a protein present in the red blood cells that transports oxygen in the red blood cells. So this hemoglobin, when it is on the electrophoresis machine or when it's on the acetate paper, it migrates through what we call electric charges. So in the first stage, it migrates through electric charges. In the second stage, it migrates through the sizes of the hemoglobin and the shape of the hemoglobin molecule. So examples of hemoglobin, basically we have AA, AS, SS, AC, and SC. But in this hemoglobin, these two hemoglobin are not common, so they are rare hemoglobin. So this migration happens on an acetate paper based on their words, their amino acids. These amino acids are like are monomers of protein. So the migration is based on the amino acids. So this is how it works. So in the previous video, I used a control which was AS. And what did I say was this control? This control is a patient sample that its hemoglobin genotype has been analyzed and is known. So it's known to be AS. Sorry. So in the previous video, I used two samples. One was control and two samples. So in analyzing, I used a control of AS. So in this AS, in the migration of this AS, you should know that AS migrates into two bonds. Two bonds like this. So one thing that will interest you to know about this two bond is how does it migrate? Firstly, I said it migrates toward the electric charge based on the size and of the molecule, size and shape of the molecule. So in the migration process, firstly, it will migrate into two bonds. And these two bonds is now for you to know that which one migrates first in these two, which of them migrates faster and which one migrates slower. So for AS, we tend to say that S migrates slower and the A migrates faster. So it's just like you interchanging it to be SA in the migration process. So A migrates faster than the S. So this migration, as I earlier said, is based on the amino acids. The migration is based on the amino acids. If you know what is amino acid, it's just like the end product of proteins. These are proteins actually, but it's just like an end product of protein. So coming to my samples. So I gave a sample, and then let's say sample A. That's sample A. This is my first sample, and if this sample happens to be AA, it will migrate and it's not fall directly under S. It will migrate and it will have a thicker bond because it is not separating. So AA is just like two persons are going on the same lane. So they'll be going and there'll be no migration, and so you know that there's a condensation. So there'll be a thicker bond. It will not be the bond will not separate. That's to tell you that there will be a thicker bond at the at the A bond. So the migration of what? Then you tend to say that this sample is AA. That is in the reading of this hemoglobin genotype. So when it comes to, let's say, sample B now, sample B, in situations where you have sample B and it migrates to directly under this S and it has a thicker bond on this S, that's to tell you that S and S is here. There's a presence of S and S bond fused in this one place. Then that's to say this patient or this sample is what? SS. So as I earlier said, it's migration based S and A. They are the what? They are the hemoglobin genotype. So they are the we say they are the variants. So it migrates based on the what? The amino acids. So if you have a sample or sample A, it migrates to this level, eh? It migrates to this level and it has a thicker bond. You should know that that sample is what? AA. And all of this happens on a paper which is known as what? The cellulose acetate. I've explained that in my what? Previous video. So we have a sample which is sample B, and the migration has a thicker bond on what? On S. So why we're using control is that if any of them falls under this one, if any of them falls under this one, because it cannot have something like this. Sample B, okay, for instance, where you have like sample B, sample C, sorry, sample C, and its migration comes like this and this. It has a double migration, that's a double bond. So this, it will tend to be what? It will be what? AS, because there's a double migration and this migration falls under S and A, because S has a slow migration and A has a faster migration. So this sample C will now tend to be AS because it has migrated into two bonds. But you should know that sample A, if it happens to be AA, it will not migrate to two bonds. It will only migrate to just one thicker bond, which will be at the A bond of your what? Of your control sample. It should be, emphasis should be made on what? The control sample. So when you have the control sample, it should be reading it based on your control. So in situations where you have other control or maybe a control of AC, because C as a variance doesn't migrate faster as compared to S. But in my previous video, I limited my work based on what? Just the available control, which was AS. So you can have other various sample control such as AC, because but I earlier said AC is a hemoglobin genotype, which is known actually, but they are rare. AC. We will even have other hemoglobin genotype as AE, as E as variants. So this is how to read the hemoglobin genotype. If you are confused, just let me know where you are confused. Please like, share, and comment and subscribe on this YouTube channel. Thank you.